Okay, so as a follow-up to our last video where the function inside the absolute value signs was always positive, so the absolute value signs were irrelevant to how the function would graph and behave. So now I wanted to change something such that the function as it sits inside the absolute value signs isn't always positive. So I've chosen one now where you can see that the absolute value signs, the operation does change what happens with that parabola. So take a look at the graph here, the preview that we get in my particular set of my particular view here. So the parabola would have come down, passed through x is equal to -5, gone down, zeroed out, or had a minimum point somewhere over here, and then maxed, and then rose through and intersected just a minute, yeah, y is equal to -5, x is 0, and y -5, that's the y-intercept that we see there. And then it would rise up through here. So the pieces of the function that are sort of staying loyal to the function inside the absolute value signs are these two wings on the side. This piece is the piece that had to change its direction when the absolute value function was applied. Okay, so I can see that when x, already, I can see that when x is less than or equal to -5, this area right here, that this function is going to be okay, this one that I can see that I haven't yet graphed. And when x is more than or equal to 1, that it's also going to be that original function. I'll show that to you using a feature in the calculator. Notice that I do not have these equal signs highlighted. That means I'm withholding those graphs for now. Okay, so when I pop down, I can press enter on the equal sign, and that will make that y2 graph. And so there you can see what the function would look like if it had no absolute value signs. And it reaffirms these two pieces that we have here. Now, if you can't, a moment to pause would be, why is it that we have those zeros at -5 and +1? Well, your job then, once you pause, is to factor that quadratic and then figure out what the zeros are by setting each factor to 0. And if you don't get -5 and +1, then you've got to do some work figuring out how to find zeros of a quadratic. Okay, that's just going to be another lesson somewhere else that you take up. Okay, so then the second thing to figure out is what happens when I take the negative version of everything. So if it's negative, I want it to be negativified, which makes all negatives positive. So there, and now I'm going to graph that one, and that's those little dotted lines. So it's just a minute. Oh, the dotted lines also go up above here. You see right there. So the dotted lines overlap that original function. So maybe it would be good if I were to make that disappear for you, the first one, so that we can see what we need of what. Okay, so there we have it in our little picture. I'll graph it on the big. So we need this piece and this piece. So we need to express when x is less than or equal to -5, we're going to have y2 in play. Also, when x is, and I think the joining word or would be useful here, or when x is more than or greater than or equal to 1, we have y2 in play. Then, when x is between the two, we are going to have y3 in play. Oops, y3 is this piece. We're going to have y3 in play. And that way we will join this piece, and this piece together to make a piecewise function. Okay, so I paused the recording for a minute to write this down for you so you could see. So what I did to create the piecewise function is I just really put math notation and symbols to what we were just talking about. So we have when x is greater than or equal to -5, or x is less than or equal to -5, or x is greater than or equal to 1, then y is equal to the straightforward version of the inside of that absolute value function.